This video is for Wednesday, July 20th, the 5th day of the semester for the summer 2. And this is first the Math 0324. And this is the last day this week of learning new material. And then you get 2 days, Thursday and or Friday, to work on the quiz as much as possible. So we're going to work on homework 6 and homework 7 in the 0342 homework today. And then quiz 1 is anything from those 7 homeworks. And you can do the quiz more than once with only the best grade counting. Okay, so assignments. So we've gotten hundreds on the first 5 of these. And now we're going to do these 2 today on Wednesday, and then Thursday and or Friday you can do the quiz. Everything's due Friday night. So in theory somebody could wait till Friday to even start homework 1 if they wanted to, but then you're kind of pushing the limit and getting all this done. And the other thing is you always want to do the 0324 first and give yourself enough time to also do 1324 stuff. So again, ideally you would take the quiz Thursday, and if you need a better grade, you can always repeat it on Friday, and then concentrate on 1324 the rest of Thursday and Friday. So homework 6 is adding and subtracting fractions. Yesterday we did multiplying and dividing. Adding and subtracting is harder for sure. Okay, so slide this over. Okay, what says find the following sum and write it in lowest terms. 8 over 13 plus 3 over 13. So 2 differences in adding and subtracting fractions versus multiplying and dividing. In multiplying and dividing, we don't care if they have common denominators. They may or may not, it doesn't affect us. We do it the same way either way. And in multiplying, you do both the tops and the bottoms. But in adding, you have to have the bottoms the same. Here we got lucky, they're both 13s already. And then you only do the top. I only do 8 plus 3, 11, and then it's automatically over 13. So the common denominator stays the same when you're adding or subtracting. You must have a common denominator, and then it stays the same. So 11 over 13, this is type a whole number or a fraction. We do have a fraction, so there it is. 1 out of 8 plus 3 out of 8. They do have a common denominator already. So the bottom's going to be 8. And then the top, that's easy. 1 plus 3 is 4. Now type a whole number or a fraction. It doesn't specify if they want us to reduce the fraction or not, although it does. I just noticed over here it does find the sum and write it in lowest terms. So 4 over 8, this is not reduced. Both of those can divide by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2. So if we didn't do that, they would have counted it wrong because they did ask for it in lowest terms. Okay, here's the first one where we don't have a common denominator. One of them's 25, the other one's 5. So if you don't have a common denominator, here's what you have to do. Four over 25 plus 1 over 5. This is problem number 3. So one thing you can try, it depends on the scenario. Sometimes you can make the smaller number look like the bigger one. So you say to yourself, is there anything times 5 that would equal 25? And this time there is. 5 times 5 is how I get 25. But if this 25 was a 24 or a 26, then that wouldn't be true. But we'll get to those later. So this one, I was able to make the smaller one look like the bigger one. Now you can't just multiply the bottom by 5 because you want it to be a 25, but if you also multiply the top by 25, then you're actually multiplying by 5 over 5, and anything divided by itself is 1. So I'm really multiplying by 1. I'm not multiplying by 5. and anything times 1 is itself, so I'm not changing what I really have. So 4 over 25 plus 5 over 25. If you were to use a calculator, and let's see if I can do it quick. If you type into a calculator 1 over 5, 1 divided by 5 is a decimal of 0.2. If I type in this new one, 5 over 25, it's also 0.2. So they are equivalent. I haven't changed anything. It looks totally different, but it's not different. But it's just needed. We need these to match each other, otherwise we can't add them. Fractions don't add unless the denominator is the same, or subtract, and then if they are the same, it stays the same. 4 plus 5 is 9. So final answer is 9 over 25, unless that could reduce, but remember we could do like yesterday. 9 is 3 times 3. 25 is 5 times 5. Those are all prime numbers. 3 doesn't reduce with 5, so then 9 doesn't reduce with 25. So the answer is definitely 9 over 25. Okay, now here's a good one, because 10, I can't multiply 10 by anything to make it a 12. Unlike the last one where I could multiply 5 by 5 to turn it into 25. So if you can't make the smaller one look like the bigger one, then you got to make them both bigger in essence. So 12 and 10 are my two original denominators. The numerators are 11 and 7. So one thing that helps on a situation like this is, let me show you a couple of things. If you list the multiples of each of these numbers, 12 plus 12 is 24, 24 plus 12 is 36, 36 plus 12 is 48. You're just adding 12 over and over again. If I start with 10 and start adding 10 over and over again, 10 plus 10 is 20, plus 10 is 30, 10s are easier, plus 10 is 40. The first time you see a number they have in common is the least common denominator. So I don't have any in common yet. Keep going here. Add 12 up here, you'll get 60. Add 10 here, 50. Add 10 again, 60. There it is. 60 is the least common denominator. Now that can get hard if the numbers are larger, or if it's just hard to add a certain number to itself over and over again. Another strategy that I've seen before is you can take 12 and 10, the two denominators, that somebody called this upside down division. And you just say to yourself, what's any number they both divide by, even if it's not the biggest number they both divide by? They both divide by 2. 12 divided by 2 is 6. 10 divided by 2 is 5. If it's not the biggest number they both divide by, then you would be able to divide again. So sometimes you can do this more than once. But 6 and 5, they only divide by 1 each. Once you can't divide anymore, if you draw a big L shape around the outsides, we're looking for what's called the least common denominator. You can do a larger common denominator, but it's making the problem harder. The numbers will be larger, and then you'll have to reduce in the end. So if we can get the least common denominator, that's the best bet. And notice that this forms a big L shape. Least common denominator starts with L. This forms an L. If you multiply all the L numbers together, that's the least common denominator. 5 times 6 is 30. 30 times 2 is 60. So there's a couple of different methods you could use to find the least common denominator. This is the hardest kind of problem where you can't do one of them, you have to do both of them. And the other advantage of this is then you can see a little more easily that it was 6 times 10. 6 times 10 is how you get 60. 5 times 12 is how you get 60. So the 12 needs to be multiplied by 5 to its top and bottom. That way 12 times 5 is 60. And then 10 gets multiplied by 6 in the top and bottom, so that way 10 times 6 is 60. And then the answer is going to have a 60 in the denominator. Now that I have both denominators the same, the denominator will be 60. Now you do need to do 11 times 5, 55. 7 times 6 is 42. 55 plus 42 is 97. Then you get what we had yesterday where maybe this reduces. And all those different strategies could be used to find that. Type a whole number, a fraction, or a mixed number, so that they're pretty lenient on what they'll take. You can do mixed numbers. I usually don't do them. They're kind of cumbersome to work with. It doesn't say reduced fractions, so I should be able to do 97 divided by 60. And improper fractions are usually okay unless they specifically ask only for like a mixed number. And you'll see this in upper level math too. We just leave improper fractions are fine. There's nothing improper about them. Mixed numbers are kind of obsolete. We don't do that very often. But you need to know about them because sometimes they do this. They're giving me mixed numbers, so I really have to be able to go back and forth if I need to. But you're pretty much best off not even dealing with mixed numbers as little as you can. So even though they're giving me mixed numbers here, 2 and 1/20th, I'm going to change it to improper. It's always easier to work in that format. 1 and 4/5. So you go down, 2 times 20 is 40, go up and add, plus 1 is 41, and then it's always the same denominator, 20. 1 times 5 is 5, 5 plus 4 is 9, same denominator, 5. So always ask yourself, can I multiply the smaller number by anything to turn it into the bigger number? If so, it's easy. That's the easiest way to get the least common denominator. And there is. 5 times 4 is how you get 20. On problem 4, I couldn't do that, but on problem 3 and 5, I was able to do that. So that way you don't even have to change this fraction. It's already over 20. The other one is 36 over 20. So the sum will be over 20. 41 plus 36 is 77. And unless they say only give me a mixed number, then this could be an answer. If they want a mixed number, we'll come back and do that, but I wouldn't do it unless they ask for it. Type a whole number, fraction, or mixed number. So you're just wasting time doing the mixed number. Plus you might make a mistake. 70. I've seen people have 77 over 20 correct, and then they try to change it to something else, and they get it wrong in the process of changing it. And anybody could have a brain cramp and make a slight mistake. I had a couple of them yesterday in the 1324 class, and then you lose credit because you had the question right, and then you go from a right answer to a wrong answer. Same deal here, except we won't have as easy as a common denominator. So 2 and 1/6. 2 and 1/6 plus 5 and 6/7. So go down, 2 times 6 is 12, plus 1 is 13. That one's 13 over 6. 5 times 7 is 35, plus 6 is 41. You can either list multiples or do the upside down division. Now, if you're doing upside down division, what if you say to yourself, what can I divide both 6 and 7 by? They don't divide by anything other than 1. Everything divides by 1. So go ahead and do that for this process. 6 divided by 1 is 6. 7 divided by 1 is 7. In other words, they didn't reduce really down. But now I can make my big L shape. 1 times 6 times 7 is the common denominator. the least common denominator is 42. In fact, if the two numbers don't have anything they both divide by, then the least common denominator is just multiplying them together, because 1 times anything is the anything and doesn't matter. So if I realize 6 and 7, there's nothing they both divide by, then I could just do 6 times 7 and get 42 for the common denominator. In fact, you can always get a common denominator by multiplying the two original denominators together. I could have done 20 times 5 here and used 100 as a common denominator. But the problem is it's not the least common denominator. And then it's going to make the numerators bigger, which means more of a chance to mess up this. And then it's really bad because then you got a lot of reducing to do in the end. So if we can get the least common denominator, that's better. But if you just have to get a common denominator to be able to do it, that's fine too. Another advantage of this is when the common denominator is both of the original numbers multiplied together, then what you do is you multiply each fraction by the other denominator. I'm going to multiply the 6 by this 7 over here. And I'm going to multiply the 7 by the 6. And that way, that's how they're both 42. 7 times 6, 7 times 6, that's both 42. Unfortunately, we're getting larger ones here. 13 times 7 for the top. 21, carry the 2. 7 plus 2 is 9. 41 times 6 is 6 and 24. So the final answer, unless it reduces, will have a 42 in the bottom. And then whatever 246 plus 91 is, 7, 13, carry the 1, 337. Again, hard to tell if that reduces. So maybe on homework at least you could just plug it in and see if they take it. 337 over 42. Yeah, that means it didn't reduce. Okay, subtraction, same rules, it's just you're subtracting the tops. So if you already have a common denominator, you're good to go. Do the top. 9 minus 5 is 4. The bottom is just stays 13. You don't do 13 minus 13. The bottom is not 0. Bottoms are the same already. So I just do 21 minus 15. The top is 6. The bottom stays 18. Although type a whole number or a simplified fraction, that actually simplifies. 6 divided by 6 is 1, and 18 divided by 6 is 3. Both of those divided by 6. So then we go back to what if they're not the same? It's the exact same rule. This is not a separate rule at all. You're just subtracting instead of adding when you finally get the common denominator. 8 over 12 minus 1/3. Can you make the smaller one look like the bigger one? Yes. 3 times 4 is how I get 12. And I was able to do that so you don't change the bigger one, and then the smaller one's going to change to 4 over 12. Now it's like the last two problems. I got a common denominator of 12. 8 minus 4 is 4. Both of these divide by 4. And 4 divided by 4 is 1. 12 divided by 4 is 3. So if you left it 4 over 12, they would say you didn't reduce it to 1/3. So these videos that I'm making this semester, I'm trying this out for the first time. I've never done this here at Lone Star College before. And hopefully they're helpful for you while you're doing your homework. I used to just email out and try to do examples inside of an email, which is hard. So I might forget sometimes about this. I'm trying to do this magic word of the day so that I can see who's watching the videos and who isn't. I'm thinking of a word now. Okay, the first letter today for your magic word of the day is M. But it's not going to be the same word as Monday. That one started with an M too. So M is the first letter. M M is in math, but it's not going to be math this time. Okay, now we get this situation where what happens if you can't make the smaller denominator look like the bigger one? 3 over 10. 3 over 10 minus something over 25. There's nothing times 10 that equals 25. 10 times 2 is 20, and 10 times 3 is 30. I can't have 25 happen. So then do your upside down division, or list your multiples. 10 and 25 both divide by 5. 10 divided by 5 is 2. 25 divided by 5 is 5. There's nothing other than 1 that both 2 and 5 divide by. So make the big L shape. 5 times 2 times 5 will be the least common denominator. 10 times 5 is 50. And in fact, if you listed multiples of these numbers, the multiples of 10 are 10, 20, 30, 40, 50. That's pretty easy. And the multiples of 25 are 25, 50, 75, 100, but we already hit a common one with 50. So there's another way to see that that's 50. So if you're doing this method, then it's a little harder to tell what to multiply by, but you could say to yourself, 10 times what is 50? 10 times 5 is 50. Here it's a little easier to see 10 times 5. It's always diagonal from it. And 25 times what is 50? 25 times 2 is 50, or it's right there, 25 times 2. So 3 times 5 makes 15 for the top. 3 times 2 makes 6 for the top, and then we already knew they were both 50s in the bottom. So the unreduced answer is over 50. 15 minus 6 is 9. 9 over 50. 9 only divides by 1, 9, and 3. Everything divides by 1. 50, all we need to know, does 50 divide by 3 or 9? No, it doesn't. So then this is fully reduced. Or you can do the methods we were doing yesterday too. 9 over 50. And then we get the same thing we had with adding. What if they are, got 3 problems left, okay. What if they're mixed numbers? Just change them to improper and don't even worry about mixed numbers anymore. 4 and 5/6 minus 2 and 2/7. Once you convert them over, then you don't have to worry about mixed numbers anymore. 4 and 5/6 minus 2 and 2/7. Number 11. 4 and 5/6, 2 and 2/7, yes. So 6 times 4 is 24, plus 5 is 29 over the original 6. 2 times 7 is 14, plus 2 is 16 over the original 7. Now here's another thing too. The more experience you get, you might remember some stuff from the past. We did one with 6 and 7 already. That was the one where they were both 42. Some people remember that, some people don't. It's fine if you don't. But, or if you have been working, you could go back and say, didn't I see that? Yeah, remember this 6 and 7? That's when they were both 42. And then you don't have to do extra work if you remembered one from the past. And then each one gets multiplied by the other denominator. So I need to multiply the first one by the 7 to the top and bottom. I need to multiply the 7 by the 6 to the top and bottom. And if you're just doing homework, it's fine to use a calculator on bigger things like this. So 29 times 7, 203. 16 times 6 is 96. Then the 42 is going to stay the same. And whatever 203 minus 96 is, 107. Since 107 is odd, it definitely does not divide by any even number. It doesn't divide by 3s or multiples of 3 because 1 plus 0 plus 7 is 8, and that doesn't divide by 3. So about the only thing we have to worry about is 7. 42 divides by 7. Maybe this divides by 7. Let's see. Does 107 divide by 7? No. It's a big messy decimal. So then this should be reduced. And then we don't need to change it back to a mixed fraction. You could, but you're just wasting your time and taking a chance you do it wrong. 107 over 42. They're taking regular fractions or improper ones, so no need to waste time putting it back as a mixed fraction. Unless they just specifically ask only for that. Yesterday we had a few where they asked for mixed numbers, we had to do it. Same kind of problem, just the numbers are smaller, which is good. 3 and 1/6 minus 2 and 1/5. 3 and 1/6. 3 and 1/6 minus 2 and 1/5. So let me give you the second letter today. The second letter is O. O is in ocean. 3 times 6 is 18, plus 1 is 19 over 6. 2 times 5 is 10, plus 1 is 11 over 5. 6 and 5 don't divide by anything in common other than 1. So whatever 6 times 5 is, that's a common denominator. 6 times 5 is 30. And then each one gets multiplied by the other one. So multiply the 6 by the 5 and multiply the 5 by the 6. Now you don't want to do this every problem. If both 5 and 6 can reduce by something, then there's a smaller common denominator that's easier to work with. 19 times 5 turns out to be 95. 11 times 6 is 66. This is definitely over 30. If I had 96 minus 66, it would have been 30. Since I have 1 less than that, then I get 1 less than that answer, 29. And 29's prime, it won't divide with 30, so we're done. And this is a proper fraction, it's not an improper one, so you wouldn't even change this back to a mixed fraction anyway. 29 over 30. over 30. Okay, last one from this 6th homework. The only difference here is they're making me do 3 fractions. One's added, one's subtracted, but do it 2 at a time. If I add these first 2 fractions, I'll get a single fraction. Once that's a single fraction, then I can subtract this one. So this is a good problem because you're learning everything from this homework all in one problem. $13 is 11 over 3 plus 1 over 6 minus 1/2. Forget the minus 1/2. Let's do this first. Can I make 3 look like a 6? Yes. 3 times 2 is 6. So then I only have to do that one times 2. 11 times 2 is 22. 3 times 2 is 6. There I got a common denominator. And 22 plus 1 is 23. So if this box was the whole problem, the answer would be 23 over 6. Now just bring this down. Start all over again. Now it's like you have a whole new problem that we were just doing the last handful of problems. And just like the original problem, this one, 2 can be multiplied by something to make 6. 2 times 3 is how you get 6. So then do the top times 3. And then you don't have to change the first fraction. 23 over 6 minus 3 over 6. 23 minus 3 is 20 over 6, but those both divide by 2, so we do have to reduce it then. 20 divided by 2 is 10, 6 divided by 2 is 3. So the final result is 10 over 3. 10 over 3. That's an improper fraction, but no problem. We actually prefer that in upper level math classes. So now we have 100% over here. 13 out of 13 on homework number 6. 6 down, 1 to go. The third letter today is N. N is in Nancy. There's all 13 of them. So one last homework in this first week of 0324. Order of operations, okay? There's only 8 questions here. So let me, before we even open one of those, let me make this list for you. Order of operations is a big part of math, because if we did not have it, then there would be mass confusion in math, and any one problem could have multiple answers, which would make computers go haywire, actually. Planes would literally fall out of the sky if that was the case. So at some point in the past, some mathematicians got together and said, we need to come up with an agreement on order of operations, otherwise any one problem could have multiple answers. So they decided, number one, you do parentheses first. And sometimes there's more than one parentheses, so then you do them inside out. Innermost first to the outermost ones. Second, you do any kind of exponent. Now, there's a little misconception on the third level. The third level is multiply or divide, but not necessarily multiply before divide. These two are at an equal level. If the dividing happens to come first, left to right, then you do that first. Some people think you always multiply first, which is not true. You have to take those left to right. Same thing with the last level, add and subtract. Left to right. You might subtract before you add. And then somebody took the first letter of each of these, P-E-M-D-A-S, PEMDAS. People call this PEMDAS. Do you remember the order? And then you got to remember PEMDAS, because that's not an actual real word. So somebody came up with something for that. Please excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. These are really good things that we have in math sometimes to help people remember stuff. There's a number of these that I have in some of my other math classes too. Please excuse my dear Aunt Sally. That means P is first, parentheses, E is second, exponents. M and D are kind of together, multiply, divide. Same with adding and subtracting. Okay, question 1. So we got this long string right here, 39 plus 56 divided by 8 times 2 equals what? Now there is a difference if it's in a long string like this versus if you start incorporating fractions. Fractions are kind of an exception, and if we see any, we'll do that. Oops. Okay. I was trying to come back here. Here's number 1 of 8 problems in homework number 7. So I've got a 39 plus 56 divided by 8 times 2. First, it's easy to notice there's literally no parentheses anywhere in there, and there's no exponents anywhere in there. So the top 2 levels are gone already. If I'm going across left to right, there's an addition first, a division second, and a multiplying third. There's 3 things I need to do, but the order matters. You don't just do them in any order you want, or left to right. But multiplying and dividing are the 3rd level, which is the first thing I'm going to do here because I didn't have any level 1 or level 2 types. But you don't multiply before dividing necessarily. You literally go left to right on those, since they're at the same level. So I have to do 56 divided by 8 first. It's a very good idea, unless you're really good at these, to do this one step at a time. And whatever you're not working on, you just bring down. So there's a 39 plus, there's a times 2. Don't worry about those yet. I decide what I'm going to do first, and I just do that one only. 56 divided by 8 is 7. That's the first of 3 steps. Now I've got a choice between adding or multiplying, but multiplying wins. Multiplying's always ahead of adding, unless you put parentheses. The reason parentheses are first is it lets you cheat the order. If I need a computer or an airplane to do some calculation and I want it to add before I multiply, if I didn't have parentheses, then multiplying would always be done for adding and there'd be no way to change that. Parentheses allow you to change the order if you need to, but we don't have any here. So we do need to multiply next. If you put a box around the part you're doing, then bring the other part down that you're not working on. 7 times 2 is 14. So we had to divide first, multiply second, here adding's last. So notice here, we divided first, we multiplied second, we added third. So multiplying, dividing, it's not that you always multiply first. This was a good example they put here because it's actually a misconception. A lot of students think the multiplying is first. It's the one downside to PEMDAS, because M's before D in PEMDAS, that's why people think that. So that's the only thing I don't like about PEMDAS. But it has such a benefit that it is worthwhile. So 39 plus 14, that's 53. So anybody that's a mathematician would agree this answer is 53. You could go to China, you could go to Ukraine, you could go to India, you could go to Africa, you can go to Europe and find somebody who doesn't speak your language. And if you wrote this math problem down and they were a mathematician, they would agree with you that the answer is 53. And if they disagree, then they're wrong. This is a fact. The only answer is 53. All mathematicians would agree this is 53. Now, any of us could make a brain cramp mistake and misadd something, but if the other person said, wait a minute, 7 times 2 is 14, not 15, if you accidentally thought it was 15, then you could, oh yeah, you're right, I made a mistake. So there's no room for debate here. Everybody says this answer is 53. Now, if you do this in a different order, you might not get 53. If I just went left to right, 39 plus 56, then divide by 8, then times 2, you're not going to get a 53 actually. So this is one nice thing about math, is usually there's only one right answer and there's no debating about it. Okay, number 2, we got a parenthesis here. So while I'm writing this one down, here comes your 4th letter today. There's 6 total letters. Today's 4th letter is K. K as in koala bear. 41 minus 4. This is number 2. 41 minus 4. Parenthesis 2 plus 6. Now parentheses can mean times. It's a shorthand way to write times without having to put in like an X or a dot. Okay, so I do have a parenthesis. Then we must do that first. No option at all. We need to do this parenthesis first. So notice I rewrote everything else. 2 plus 6 is 8. Had to do that first. So there's 2 things left. There's a subtraction, and this is understood to be multiplication. Well, multiplying definitely comes before subtracting unless there's parentheses. So I'm definitely not going to do the subtracting yet. Rewrite that. Put a box around what you're doing. I'm doing 4 times 8, which is 32. Whoops, I wrote that funny. 41 minus, bring that down. 4 times 8 is 32. Now all that's left is subtracting. 41 minus 32 is 9. Number 3, now it's starting to get good. Now we've got all 4 levels of the order of operations. There's parentheses. In fact, there's parentheses inside of parentheses. There's an exponent, there's a plus, there's a times. We have all 4 levels now. Not every problem has all the levels either. So 8 times 4, 8 times 4 plus 1 cubed and we got a parenthesis and a bracket. So we would do the innermost parenthesis first, rewrite everything else. 1 to the third power. 1 to the third power literally means 1 times 1 times 1. But you can multiply 1 by itself as many times as you want, and the answer is still 1. Now, if you get your parenthesis down to a single number, 1 to the third is 1. And if it's not being used as a multiplication symbol, because we have adding right here, then it's okay to drop that individual parenthesis. So I would rewrite it like that. Since that's not a times 1, I don't need the parenthesis anymore. So now I've got the outer parenthesis 4 plus 1. Here's where I'm going to add before I multiply, just because it's in parentheses. 4 plus 1 is 5. Now that I have it down to a single number, in theory I could drop the parentheses, but I need to leave them there because that means times right here. Unless I want to put the dot or the X to mean times, then you could drop the parenthesis. But you can also leave it like this so that it means times. And then either way, that's the last step. 8 times 5 is 40. Okay, they are fractions. So fractions is kind of its own rule. The only thing about fractions, let me add this to the list. It's not really in the order here. It's just an extra rule to know. In fractions, there's implied parentheses around the top and the bottom. So if you have a fraction instead of a long string of things, you just kind of treat the top and bottom separately. So get the top to a single number. And the bottom to a single number. Then divide last. This sort of violates the rule of order of operations because you normally would not add or subtract before you divide. But let me show you these two cases here. I got to think of an example that works well. 8 plus 12 divided by or over, let's do 3 minus 1. If it's written like this versus written in a long string, 8 plus 12 divided by 3 minus 1, you get a different answer actually. So in this second case, this is the kind we've been working on. In this second case, you would do the division first and get 4. Bring everything else down. Then you would go left to right and get 8 plus 4 is 12. And 12 minus 1 is 11. In fractions, there's implied parentheses around the top and the bottom that they don't write. But if it helps you, do it. There's parentheses around the top, there's parentheses around the bottom. So that's why it's done differently, is you actually have to do the parentheses first, even though you won't see them in an actual problem. 8 plus 12 is 20. 3 minus 1 is 2. 20 divided by 2 is 10. Notice the answers aren't the same. And sometimes they're quite different. In a rare case, they might by coincidence be the same thing, but they're usually different. So it's just kind of its own rule that fractions, try to get the top down to a single number first, then get the bottom down to a single number, and then you divide those two last, even though that's not normally the last step. I got the top down to a single number, 20. I got the bottom down to a single number, 2, and then I divided 20 by 2. It's just kind of an exception to the rule of order of operations. So our problem number 4 has a fraction, 28 plus 2. Then there's a parenthesis for 2 squared minus 1. But it's understood that there's like a big bracket around this entire numerator. I have to get that all the way down to a single number before I worry about anything else. The bottom is 3 times 2 minus 4. But it's like that one's got a parenthesis around it too, even though they don't write them. So I'm going to do the top all the way down until it's a single number. So if this was my entire problem right here, I would say, okay, I see a parenthesis. I got to do that first. And in the parentheses, there's 2 choices, square or subtract. Squaring would go first over subtracting. So 2 squared is 4. Don't worry about the bottom yet. So now I can finish that parenthesis. 4 minus 1 is 3. Because it's multiplied, I need to keep the parenthesis. If it wasn't multiplication, I could drop the parenthesis once it's a single number. So I am going to multiply before I add next. So 28 plus 2 times 3 is 6. I finally have the top down to a single number. It's 34. So in the bottom, multiply or subtract, you would multiply first. 3 times 2 is 6. Then you would subtract next. 6 minus 4 is 2. If one half of the fraction gets done before the other, then just bring it down like I just did there. 34 divided by 2, now we divide last. You normally don't divide last in order of operations, only if there's fractions involved. 17 is the answer. See, this is why they only have 8 problems in this homework, is because these kind of take a while. Now it's really getting complicated. Okay, so there isn't parentheses around the top or the bottom, but remember they're implied. And then we got a bunch of parentheses inside as well here. 8 times 8 plus 7. Number 5. 8 times 8 plus 7. Plus 3 times 5 minus 1. The denominator is 15 times 8 minus 3. Minus 4 cubed. So I'm just going to keep working the top till it's a single number. I'm not going to worry about the bottom till that point. So in the top, I've got a couple of parentheses that I would have to do first. 8, and I'm going to keep the parenthesis just because it's times. 8 plus 7 is 15. Rewrite the plus 3, and then do this one. 5 minus 1 is 4. I'll keep the parenthesis because it's times. So I got to either multiply, add, or multiply. Multiplying comes before adding if you don't have any bigger parentheses. So 8 times 15 equals 120 plus, I do 8 times 15 plus 3 times 4, 12. So finally, I have the top down to a single number. 120 plus 12 is 132. Now go back and get the bottom down to a single number. Parentheses would go first. 8 minus 3 is 5, so 15 times 5 minus 4 cubed. Exponents would have to be next. So rewrite your 15 times 5 minus 4 to the third means 4 times 4 times 4. 4 times 4 times 4 is 64. I would need to multiply before I subtract. 15 times 5 is 75. This time the top got done before the bottom did. The last problem, the top took like 5 steps and the bottom was done in 2 steps. So rewrite the top since that one's already done. The bottom has 1 step left. 75 minus 64 is 11. Now we divide last. 132 divided by 11 is exactly 12. So there's the final answer to number 5. 12. The next letter of the magic word of the day is E is an egg. Okay, here's something you haven't seen yet. If you put bars around stuff, vertical bars, that's called absolute value. But it acts like a parenthesis, so you will do that part first. But it has its own rule about how it gets simplified to the final result. Number 6. -3, absolute value, 3 minus 5, plus 5 squared. So absolute value, those are bars, but they qualify as parentheses. I need to do that first. And then it'll be down to a single number. So 3 minus 5 is -2. Here's the rule about absolute value. Did I skip this one? No, there's stuff there. Okay. Well, I'll just put it here anyway. So absolute value of 4 is 4. Absolute value of -4 is 4. That's the rule. If you're doing the absolute value of a single number, the answer is automatically positive. If you do absolute value of multiple numbers like we had, it does not change this to a plus. Some people think that it changes every individual number to a plus. It doesn't. You have to do 3 minus 5 and get -2, and then the absolute value -2 is +2. But don't say, oh, that would change to a plus, and I would have 3 plus 5, 8, and then the answer would be 8. So the absolute value of -2, now if I want to get rid of the absolute value bars, that changes to 2. And there's nothing there, so I can either put a dot for times or a parenthesis, whatever you like better. So now I have 3 things left. I have a times, a plus, and a square. Got to do that exponent first. So I rewrite everything else. I want to do 5 squared next. 5 times 5 is 25. Now I decide between multiplying or adding. Multiplying wins that battle. So -3 times 2 is -6. Remember, we did those the other day too. Multiplying a positive times a negative is negative. And we did some of this the other day too. When you're adding or subtracting where one's positive and one's negative, you put the bigger one first and subtract them. And then the bigger looking one determines the sign. So the answer is positive 19. That's why we had those earlier homeworks, because it comes up when you're doing this kind of stuff. That's how math, it always builds on itself. Stuff from the past is going to keep coming up. So 19. So the only thing different on this problem was absolute value you might not have seen for a while or ever. 19. Okay, I see where they're going with this one. Okay, so, but it's similar to the other ones we had with fractions. Try to get the top down to a single number. Try to get the bottom down to a single number. Then you divide them last. So the top of my fraction is 4 times -4 plus -2 times -6. I'm not even going to look at the bottom yet. I'm just going to do this. So I got 2 multiplyings and an adding. If there's 2 multiplyings, you can do them at the same time if you want. It's the same level. 4 times -4 is -16. That's something we did earlier. And -2 times -6 is +12. and then you can bring this plus down. So now I'm adding a negative and a positive. That's where you subtract their values. 16 minus 12 is 4, but the bigger looking one is negative, so negative 4. So I got the top down to a single number, negative 4. The original denominator was negative 9 plus 4 plus 5. Negative 9 plus 4 plus 5. So the negative is with the 9. I really have two things here, and they're both plus. So just go left or right. Negative 9 plus 4 is negative 5, because the bigger looking one's negative. We had some of these the other day too. Negative 5 plus 5, that's 0. If one's positive, one's negative, they're the same, it's 0. Now this is the point they're trying to make. In a fraction, you can get 0 divided by some number. That's actually different than some number divided by 0. And let me show you why. If you do 0 divided by any number, whether it's positive 4 or negative 4, there's a plus minus button here. Here it is, negative 4. That's 0. I'll say it this way. 0 divided by any number is 0. But we didn't have that case. We had negative 4 divided by 0. And this is a special case. This is what they call undefined, because you cannot divide by 0. Think of it this way. Let's say it was 4 over 0 and 0 over 4. If I have $0 and I want to divide it up among 4 people, well, each person gets $0. They just sit there and they get nothing. But if I have $4 and I want to give it to nobody, how does it just disappear from the earth? It would be like $4 disappearing into thin air. It's going to nobody, but how can it go to nobody? Am I just going to drop it on the floor? But then somebody could pick it up. So there's no way for $4 to go to nobody. Somebody's going to find it eventually. So there's no way to divide $4 to nobody. So that's called undefined. But I can divide $0 among 4 people and give them all nothing. They'll be upset, but at least they're there and nothing paradoxical happened. So it's easy to get these two mixed up on quizzes or tests. Where are we? But this, if it's 0, you put that in the box. But if it's undefined, they usually have a box you just check, because apparently the computer can't grade that if you type undefined. That one's undefined. Okay, last problem, and this one seems pretty complicated. The bottom's not too bad. You got to do the top and the bottom down to single numbers. I guess you could do the bottom first, but pick one and just do that one and all the way down until it's a single number. Maybe you want to, if one's much easier than the other, maybe you want to do the easier one first, just so you can get some partial credit, or if time's running out. Negative 13, negative 26, or minus 26, plus 5 times 8. So don't count the front negative. You have a subtraction, you have addition, and you have times. Multiplication's definitely first. I'm definitely going to do this first. I don't have any parentheses. I don't have any exponents. Rewrite negative 13 minus 26 plus. Now just do 5 times 8, which is 40. So now I got to choose between subtracting or adding, and that's the same level, so you got to go left or right. So we have to do negative 13 minus 26, or negative 13 plus a negative 26. So we did some of those the first day. If they're both negative, then you add them together and the sign stays the same. So the value is going to be 39, but it'll be negative 39 since they're both negative. Remember how that's easy to mix up with multiplication? In multiplication, 2 negatives make a positive, but in adding, 2 negatives make a bigger looking negative. And then finally, I'm going to add 40. There's 1 positive, 1 negative, so subtract them. And the bigger looking one's positive, so the answer is 1. I got the bottom all the way down to a 1. Now for the messy top, 4 minus 4. Then there's a parenthesis that's a fraction, which is kind of weird, fractions inside of fractions. There's a minus 5 at the end. Maybe the fraction comes out nice. The fraction is -2 minus 4 over -3, and it's inside of a parenthesis. So if we only had the top of this problem, we would do that parenthesis first. And since it's a fraction, you have to get the top down to a single number. The bottom's already a single number. So I'd have to do -2 minus 4 or -2 plus -4. That's where you add them and keep the sign. So that would be -6. -6 divided by -3 is +2. Rewrite everything else. Or I don't remember if that was times or minus. Let me check. It was minus. Okay. I couldn't read my own right. I didn't know if this was times or minus. It's minus. 4 minus 4 times 2 minus 5. So I would have to multiply next. 4 times 2 is 8. 4 minus 8 minus 5. Now that it's all subtracting, I go left to right. So 4 minus 8, the bigger one's negative. So 8 minus 4 is 4, and then make it a -4. Now they're both negative, so now you add them together and keep the negative, -9. And anything times or divided by 1 is itself, so -9 is the answer. This one was definitely kind of messy, but it did come out nicely. -9. I just can't get it in there. There we go, -9. And they left an option for undefined, but that would only happen if the bottom is 0. Okay, so now we have finished all 7 homeworks in their entirety. Save. And if I go back into the assignments, there, all those are done. And you see that all the way at the end, 100, 100, 100, 100, 100, 100, 100. So you don't have to get hundreds on them all, but obviously the more higher they are, the better your grade's going to be. But you do need these all to be at least 70. Then you'll be able to start the quiz. You can even do the quiz on Monday, Tuesday, or Wednesday of a given week if you already have 70s on all of these. But I would wait till you're done with them all. So hopefully you're striving to get 100 on everything if you have the time for it. And then if you do have 100 on everything, that's probably a sign you're ready for the quiz, and give it a shot because this one has an unlimited number of attempts. Try to get this quiz out of the way by Thursday at the latest, so you got plenty of time for the other class, because then you got to review and test in the other class. So this is the last video for this week for 0324, and you're just going to practice this as much as possible. Take the quiz at some point by Friday. All this is due by Friday. Anything you don't finish, it'll just submit it as is. So if something's a 50 and you never come back to it, it'll be a 50 when the deadline passes. If one of them you haven't even started, it'll turn into a 0. Your final letter of the day for the magic word is the letter Y, as in yes. So you can email me the magic word of the day for this Wednesday. This video was for Wednesday, July 20th. The 3rd day of videos. I sent a video out on Monday, Tuesday, and Wednesday of July 18, 19, 20. And then you get Thursday and Friday to do the stuff you got to do. Saturday and Sunday are days you don't even need to work on unless you want to. So next week, Monday, Tuesday, Wednesday, July 25, 26, and 27, there'll be a video each day for each class as well. And for the 0324 class, there'll be a word of the day to send me. So I'm signing off for the 0324 class for this week. 1324 still has a video coming out on Wednesday, July 20th.